Welcome to Sundar's lecture. This is lecture number 10, and in this lecture we are going to see grouping of cells for K-map. For example, we will have pair, and then quad, and then octet, and how to group those cells. And to group those cells, what are all the basics we need to understand in the Karnaugh map. That is what we are going to see in this particular class, right? So, what are all the topics we have seen in the previous class? So, we have taken the Karnaugh map basics, and then we have just um, written the output bits inside the K-map for 2 variable, 3 variable, and then 4 variable, maybe 3 input, 4 input systems, right? So this is what we have seen in the previous class, right? So now in this class we will see grouping of cells. So first one, we need to understand what is a pair, and then the second one, it is quad, and then third one, it is octet, right? These three uh, names we generally use in the Karnaugh map. Before that, we have to understand the adjacent cells. Adjacent cells. What is adjacent cells? Because in Karnaugh map, for example, two variable Karnaugh map, if you take two variable Karnaugh map, it is not an issue, and we generally we are not going to use the two variable Karnaugh map because it is very simple to, right? So this is these two are adjacent to each other, and these two are adjacent to each other. That means this cell is next to this one, as well as this cell is next to this one. So, and also this cell, these two are adjacent, as well as these two are adjacent. Try to understand, these two are adjacent, these two are adjacent, because this is a four variable, four different combinations will be there. So it is very simple to understand. But if you take three variable, this is actually two variable. Two variable in sense was two input system. That's all. And if you take three variable, maybe I will write here three variable K map. Three variable K map. What is the uh, three variable K map? We have seen, right, already. The like this. 8 combinations will be there. 8 combinations will be there like this. 1, 2, 3. Right. Now, so I'm not writing these kind of things, A, B, C, and I'm not writing those kind of things, right? So, for example, these two are adjacent to each other. These two are adjacent to each other. These two are adjacent to each other. As well as these two are adjacent to each other. 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 Try to understand one thing. In Karnaugh map, you can fold the map like this, or you can fold like this also. Always you can also fold like this, but anyhow, if you fold like this, these two are adjacent, we have already told. But if you fold the K map like this, if you fold it down, so this cell, this this particular cell, this cell and this cell is adjacent to each other. Try to understand. If you fold like this, what happens then? These two cells are adjacent. That is why I want to tell you the idea. These two are adjacent cells, as well as this cell and then this cell. These two are also what? These two are also adjacent cells, right? This is the whole idea, right? So if I take 4 variable K map, then we will go up to 4 variable, and then I will explain you 5 variable K map, right? So first we try to understand the basics of 4 variable K map. If you know 4 variable K map, how to simplify it, then it is very simple to do the 5 variable K-map also, right? If I take 4 variable K-map, for example, to understand 4 variable, how many number of combinations are there? 16 number of combinations will come, right? 16 number of combinations. So this will be 1, 2, this is 3, right? 3. And also 1, this is 2, and this is 3, right? So we know the numbers to understand. If I put 0, 1, this is 2, this is 3, and then 4, 5, this is 6, this is 7, this is 8, 9, 10, this is 11, 12, 13, this is 14, this is 15. What is these numbers? What is these numbers? These are all min terms. These are all min terms, right? So, for example, in this one, you can easily understand. See, these two are adjacent to each other. These two are adjacent to each other. These two are adjacent to each other. As well as these two are adjacent to each other. This one and this one are adjacent to each other. Next cells. Next cells. That is the whole idea. And also this one, this one, this one. Also these two, these two cells. Likewise, every adjacent cells, right? You can easily see by your naked eyes by looking into this diagram, right? So these are all adjacent cells. These two, as well as these two, and these two, as well as these two. But now I've told you I can fold the K-map like this. So what happens now? This one and then this one are adjacent cells. For example, 0, 2 are the adjacent cells, right? And so we have seen, right? So 0, 2 is adjacent cell, as well as this 6 and then this 4. Try to understand. So I will write it here. 6, 4 also adjacent cell, and this 14 and this 12 is the adjacent cell. Which one? 14, 12 is the adjacent cell, as well as this 10 and this 8 is the adjacent cell. So this 10 and then 8. I'm writing min terms, try to understand. I'm not giving any numbers. I'm directly writing as a min term. So these are all adjacent cells. And you try to understand. I fold the map like this now, so that 2 and 0 are adjacent cells. I have understand, as well as 6, 14, 10 with respect to 4, 12, 8 are the adjacent cells. And if I fold map like this, because it is a 4 variable K-map, right? I can fold like this also, and also I can fold like this, right? So what happens now? This cell and then this cell is adjacent to each other. So here I will write number 5. 0, 8 is the adjacent cell, as well as you see this one, this one, this one is the adjacent cell. 1 and then 9. 1, 9, and 7th one, this 11 and then this 3 are the adjacent cells. 3, 11, and number 8, this 2 and this 10 is also adjacent to each other. 2, 10, right? I can fold map like this, so that this whole 2, 6, 14, 10 and 0, 4, 12, 8 is adjacent to each other separately, right? And if I fold map like this, so this 1, 0, 1, 3, 2, 8, 9, 11, 10 are adjacent to each other separately adjacent to each other. For example, I will ask you one thing. If I fold like this as well as like this, then what happens? Try to understand. I fold map like this and as well as like this, and so now what happens there? This 0, this 2, this 8, this 10 will come closer to each other. Try to imagine things now. Try to imagine. Fold both maps, both sides. This side as well as this side. Then what happens? This 2 and this 4 will come closer to each other, as well as this 10, this 8 will come closer to each other if I fold in both ways, like this also, like this also. So we generally say this 0 comma 2 and then 8 comma 10, these are all closer to each other or adjacent to each other. It will come like this. It will come like this if I fold map like this as well as like this. So if this will come when quad presents. So we will see it on quad, right? But the idea you have to understand, right? So what we will do now, we will take the Karnaugh map and we try to understand what is the pair. First we will go for pair. First we will go for pairs, right? Pairs. And how to write pairs and what happens if pair comes, right? So first what I will do, I will take the Karnaugh map, I will draw the Karnaugh maps. Right, right. Now, what we will do, we will understand with three variable k map. First, we try to understand, right? For example, I am not going to write the equation. I am not going to give you the Boolean equation and writing the with min terms. I am not going to do that. First, we try to understand what is pair, right? For example, if I have values like this, this is 0, 0, 1, 1, 0, 0, 0, 0. If I have a expression like this, right? These two are only 1, 0, 1, 2, 3. Only minterm 2 and 3 are the outputs of minterm 2 and 3 are 1. Maybe I have not list you the minterms 2. This is 0, 1, 2, 3, 4, 5, 6, 7. We know, right? We have already seen those kind of things. These two outputs are 1. Then how to simplify this one? That is the whole idea. See here, if two ones are adjacent to each other, this one, two ones are adjacent to each other, adjacent to each other, right? So that is the thing. These two ones are adjacent to each other. We are calling it as pair. We are calling it as pair. So now you take this particular K map and see these two ones are adjacent to each other. So what is this one? This can be taken as a pair. And how you are going to write down the expression now. For example, the simplified version of expression y will be is equal to, see here, these two are pair, right? So you go straight here, and what is this value? There is only a single variable, so you straight away write that as a bar. You cannot do anything for this two, and these two are now pair. So you go in this side, two cells are there, and you can see these two, compare these two expressions. This is BC, this is BC bar. What is the common term here? What is the common term here? The common term is what? It is B. Can you understand? It is B. So what you have to write? This is B. Can you understand? So you have to compare these two, and this is the simplified version. This is the simplified version. The output is A bar B. That's all. That's all, right? So can you understand? A pair can reduce a single variable. One variable can be reduced because this is a three variable K map. This is a three variable K map, and your output Y expression would have been A bar B C A B C. If you write it in canonical form, you'll have three variables, right? But what this pair will do, the pair will reduce one variable. One variable. That is the idea. See, I will write here. Maybe you would have an expression like this, right? Y is equal to A, B, C bar plus A, B bar, C, whatever it may be, A, B, C, and you have an expression like this. But the simplified version of this one, for this output, it is Y is equal to A, B bar, right? Sorry, what is that? A bar B, right? So A bar B. So what actually we are doing, we are just reducing three variable to one variable. So one variable will be reduced in pair, in pair. That is the idea. That is the idea. See, this one is, these are all ideas, right? So now this is how you need to write the values, right? Now I will take another example, right? Now you see here. Now you see, I have a output like this. Now these two ones are adjacent to each other. We know, right? These two cells are adjacent to each other. So this is one pair. This is one pair. How will you write the expression now? Y will be is equal to these two. So straight away you see this one. This is BC, right? So straight away you can write BC, and you come here. You have to compare these two cells. If this is A bar, this is A. There is no common term. There is no common term. That's all. You don't need to write anything. So BC is the answer. Y is equal to BC is the answer, right? So now what I will do? I will take another example. Maybe if I have a 1 0 0 0 1, not 1 0, maybe like this 0 0 0 0. For example, if I have like this, then I have told you, right? These two cells, if I fold the came up like this, then these two cells are adjacent to each other. So what you can do here, this one and this one is a pair actually. This is also a pair. So how you are going to write the y expression? So for this I will write here, y will be is equal to, see here, I have to take this one and this one. Straight away you see this is a bar. So you write this a bar, and you have to compare this one and this one. Try to understand these two. What is the common term in these two? C bar is the common term. So C bar is the answer. A bar and C bar is the answer. Try to understand, right? So this is how you need to get a pair, right? Right now, if I go to 4 variable schema, 4 variable K-map. For example, what we have done here, we have taken 3 variable K-map and we have concluded that the output is coming like A bar, C bar, BC, A bar, B. One variable has been reduced if a pair is there, right? So, for example, if I am going for K, like this, a 4 variable K-map, right? Let me write the output equation, any output equation, maybe this is 0, 0, 0, 0, 0, 0, 0, 0, 1 0 0 0 0, this one 1 0 0 0 0. For example, if I have an output like this, I have told you, right, I can fold came up like this as well as like this. So what happens here? What happens here? These two, now this one and this one is the adjacent cells, so it is a pair. It is a pair. So how you are going to write the y expression here? That is the whole idea. Try to understand. So if I see straight into this, CD is there. There is only one value. So I can put CD directly here. CD directly here. But what I have to do, I have to see here this cell, this cell, this cell, and then this cell. I have to see this both cells. I have to see what is the common term. What is the common term? B bar is the common term, right? Because these two are adjacent. B bar is the common term. So I have to write B bar. I have to write B bar. See this, for a pair in a 4 variable K map, I am getting 3 variables. So the point is pair reduces one variable. Pair reduces one variable. Even if it is a 3 variable K map, we are getting 2 variables. One variable has been reduced. As well as in the 4 variable, you are getting 3 variables. So one variable will be reduced if it is a pair. Try to understand, right? See, now I am going to explain you overlapping pair. Overlapping pair. What is overlapping pair? For example, if I have an output like this, let me have output like this, right? 0 1 1 0 0 0 1 0. For example, I have the ones like this, the output is like this. Then I can easily say I can easily say these two variables are adjacent to each other. So this is one pair. This is one pair. So what I have to write here, y should be is equal to, I have to see straight into this. This is a bar. So I can write a bar straight away. And then what is the common term in these two? C is the common term in these two. Right. I have completed for one pair. But there is another one here. Another one is available here. So what I have to do, I need to take this as a separate one? No. If there is a possibility of a pair, then you have to go for a pair. If there is a possibility of a pair, then what you have to do? You have to go for that pair. So I can take this two ones as another pair. These two ones as another pair. Try to understand. This is how this one is now a overlapping one. Overlapping pairs. This one is comes in this pair as well as in this pair. If there is a possibility of pair, then go for that pair. That is my idea, right? So how will you write this one? So you have to put plus, because whatever you are seeing here, it is a SOP function. I am not gone for POS still. A K-map for a POS function is a different one. So the next term, I have to put plus. I have to see this one, BC. I can straight away write BC. But if I see this one, A bar and A, there is no common term. That's all. This is the final answer. This is the final answer. Simply I can write like this. As well as if I take a value like this, for example, this is 0, 1, 1, 0 and 0, 0, 1, 1. If I have like this, for example, because why I am telling this one, this is very important to understand. So if I see this one, these two are adjacent to each other. So I can write straight away should be is equal to, this value is A bar, this value is A bar, and if I compare these two, I am getting C. That is the first one. Plus, put plus because another ones are there. And if I take these two as a pair, then what is the answer? A is the straight answer. And then if I compare these two cells, B is the common term. So I can put B. I am asking you, should I map this two as a pair? That is also an overlapping pair, right? So what is my ultimate aim in a Karnaugh map? I have to cover all the ones. If I covered ones, all the ones, for example, you take this K map, I have covered all the ones, right? So these two I have covered as a pair, these two I have covered as another pair. If there is no ones are available separately, there is no one is available separately, then you should not make anything, any pair or octet or quad. We are going to see all the different kinds of groupings. You should not do. You should not do. Try to understand. You should not map these two as another pair, because I don't have any other ones. I don't have any other ones. For example, if I have the same example, I will write like this now. This is 0, 1, 1, 0. This is 1 now, 0, 1, 1. For example, you take like this. For then what we will do generally, we will take these two as a pair. So y will be is equal to this same thing, right? This is A bar, this is A bar, and these two, what is the common term? This is C. Then plus these two are the another one pair. So this one is A, and then what is the common term in these two? This is B. Try to understand. And now you have to understand. See this, there is a one separately out here, and I have to cover that one. That is my ultimate aim. In a Karnaugh map, I have to cover all the ones effectively. Right? There is a separate one I should go for. Is there any possibility of pair? Is there any possibility of pair? Yes, is that the possibility of pair is there, because I can make this one and this one as a pair. Can you understand? This one, these two are adjacent to each other, right? So then what is the answer? I can see straight away this one, this is A, and I have to compare this one and this one, right? Because these two ones are here and here. So the common term is C bar, right? This one and this one is C bar. I can write C bar. Now I am asking you one question. See, here I have completed all the ones. My ultimate aim is done. Okay. Should I map these two as a pair? No, 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 no. You should not go for these two as a pair because I have already completed. I have already covered all the ones. So don't go for this one. Try to understand. Try to understand. Right? Now, for example, we will take into 4 variable K map. Actually, the meaning of overlapping is this one. This one. Try to understand. This pair and this pair is a overlapping pair, right? So you should not do this one. That is my whole idea. Try to understand. Try to understand. This is the beginning classes, and while we are practicing more number of problems, you can easily understand things, right? Right. Now, now you see. If I have like this, these are all ones. So straight away I can write or take these two as a pair. So y will be is equal to, what is the output for this one? So there is no common term in these two because a bar is not a common one, and I can straight away write this is BC, right? The answer. For example, see this one now. This is one. There is another one. I have to make it to account. Make this one into account. Maybe you see here. Can I make a pair here? No, not a possible. Not possible. And then I can see these two cells, right? These two are adjacent. This one and this one is adjacent. Can I make a pair like this? No, this is 0. I cannot make a pair for this one. And I don't have one here also. So I cannot put these two as a pair. Then what I have to do here? That is the question. That is the question. I cannot make a pair with this one. So if there is no possibility of pair, then you have to take this one as a separate term. As a separate term. And how will you write the expression? Put plus now. How will you write the expression? What is the value? What is the variable is here? It is a bar. It is a bar. And what is the variable is here? Straight away. This is b bar c. That's all. You have to write. If there is no pair for a particular one in a 3 variable K map, then the answer will come as a 3 variable. There is no reduction. There is no reduction for this particular one. That is the whole idea. Right? Can you understand? That is the whole idea. Right? So we will see much more things in quad and octet in the next class. So what are all the topics we have seen in this class? Group, we have started with the grouping of cells, and in grouping of cells there are 3 different pairs, quads and octets are available in K-map simplification technique, right? So what we have seen, we have tried to understand what is adjacent cells, right? So if it is a 3 variable K-map and which are all the cells are adjacent to each other, and these two are adjacent, these two are adjacent, and we have seen. And also for 4 variable K-map, you can fold the map like this as well as like this. And then I have also told you this 2, 0, 2, 8, 10 are also adjacent to each other, right? So we have seen, and then we have gone for pairs and overlapping pairs, right? So we will see quads and octet in the next class. Thank you.